Alrighty, so this is your review for the practice final exam. Once again, for every point you get correct on the practice final is one extra credit point with a possible of 50 extra credit points that can be added to your total points earned. Okay, not to the total points earned for the class, but just to your total points earned. Okay, so now let's look at the first one. And what I'll do is get you started with these problems, not necessarily give you the answers. I may give you answers to a few of them, but not to all of them. But just pretty much get them set up for you so you can execute the rest of the problem. Alright, so for the first one, it says, what is the x-coordinate of the point of intersection for the two lines below? In this problem here, we're dealing with the linear system. And if you recall, three ways to solve a system is by graphing, elimination, or substitution. Now, it's more than obvious that substitution is the ideal way to solve this problem, since the second equation is already solved for the y variable. In other words, y equals negative 6x plus 40. I am going to substitute in the first equation that expression, negative 6x plus 40 in for y. Now what you have here is a linear equation in terms of one variable, which you should be able to solve to get your answer. And once again, the problem is asking for the x-coordinate only, so you don't have to find the y-coordinate, just find the x-coordinate. And once you solve this equation here, it will give you the x-coordinate. Okay? Let's look at question number 2. Now 2 is asking for the y-coordinate. What is the y-coordinate of the point of intersection for the two lines below? Now this system here is a little different from the first one. Substitution is not the ideal way to solve this linear system. The ideal way to solve this system is to use elimination. So like stated before in the class, it doesn't matter what variable you choose to eliminate, just choose a variable. I am going to choose to eliminate the x variables. In order for the x variables to eliminate, alright, so this term here needs to be a positive 6x. So I'm going to multiply the entire second equation by 3. So I didn't do anything to the first equation, so it stays the same. The second equation becomes 6x minus 9y is equal to 12. Now if you recall, when you're doing elimination, you simply add the two equations together, and when you add those two equations together, you want a variable to eliminate. So it's quite obvious that the x variables will eliminate when I add straight down. So I get negative 2y is equal to 32, and you should be able to finish it from there. Okay, only find the y coordinate. Question number 3. So now this one is asking for the number of solutions. How many solutions does the system have? Now I like the way Dr. Berger does it on the videos. He put both equations into slope-intercept form, and when the equations are written in that form, it's quite obvious to figure out how many solutions you're going to have. So for that first equation, let's look at putting it into slope-intercept form by first subtracting x from both sides of the equation. And I get y is equal to negative x plus 4. And the second equation, let's put it into slope-intercept form. So let's add 4x to both sides of the equation first. I get negative 2y is equal to 4x minus 8. Let's divide every term by negative 2 now to get the y variable by itself, and you get y is equal to negative 2x plus 4. Alrighty, now go to page 407 in your ebook, and there's a chart on that page. All right, if you identify the slope and the y-intercept, You then should be able to determine how many solutions this system have. Okay, so refer to your ebook, page 407, and identify the slope and the y-intercept for these two equations, and you'll find the answer on that page. Okay, question number 4. Once again, how many solutions does a system of linear equations have? All right, so once again, let's put both equations in slope-intercept form, just like the first one. All right, and refer to page 407. And if you're able to identify the slope and the y-intercept of both equations, you will find the answer on page 407. So number 3 and number 4 are exactly alike. All right, number 5. It says which ordered pair which ordered pair is in the solution set for the system of inequalities shown below. All right, so now for this one right here, guys, simply plug in the points. Okay, simply plug in the points. In order for a point to be a solution to this system here, it must be true in both equations or both inequalities. All right, so let's just do the first one. Okay, and so x is equal to -2 and y is equal to -1. I'm going to take those values and plug it into the first inequality. My first inequality is this. So everywhere I see an x, I'm going to substitute a -2. And everywhere I see y, I'm going to substitute a -1. And I get -4 plus 1 is less than 3. -4 plus 1 is -3. It's less than 3. So is this a true or false statement? Okay, I think it's true. -3 is less than 3. Now we do the same thing for the second equation. Everywhere I see x, I plug in -2, and everywhere I see y, I plug in -1. And we want to see if we get a true statement. So -2 plus -2 is greater than -1. So -2 plus -2 gives me -4. Now, this statement is false. -4 is not greater than -1. So therefore, A is not a solution. So you have to go through and determine which one is a solution. So you know it's not A, so it's got to be B, C, or D. So you do the rest of it and figure it out. Watch out for your algebra. Okay, number 6. Which system of inequalities is shown in the graph below? Assume the tick marks represents 1 unit. Alright, use your graphing calculator from your ebook. Go to your ebook, pull up your graphing calculator, alright, and graph each one of these systems here. Alright, and it's quite nice because in every single problem, each system is written in slope-intercept form, so you don't have to put it in slope-intercept form. Graph them. The one that matches this is going to be your answer. Okay, so use your graphing calculator. Alright, and then just graph it and see which one matches. Now just be very careful. Remember, if you have greater than or equal to, or less than or equal to, your line will be solid. If you have greater than or less than, you will have a dotted line. Now, if you recall from the ebook, they don't show dotted lines. They make the dotted line really thin and make the solid line really thick. Okay, so pay attention to that, please. Pay close attention to it. All right. Number 7. Okay, another system here, and as you can tell, all these problems are coming from chapter 6. Yolanda has 30 coins worth $2.35. She has only nickels and dimes. How many nickels does Yolanda have? All right. So in this problem right here, there's two things we don't know. We don't know how many nickels we have. So I'm going to say X equals the number of nickels. And we don't know how many dimes we have. So Y is going to equal the number of dimes. Now we need to write two equations that involve X and Y. Now, just reading the first sentence or part of the first sentence, it says Yolanda has 30 coins. All right. So I already know that if I add up the total number of nickels I have and with the total number of dimes, it's going to give me the total number of coins. So my first equation is going to be X plus Y is equal to 30. Now also from the first equation, I know that when I add up or I actually count the total amount of money that I have, it would be $2.35. So since a nickel is worth 5 cents, I'm going to take the decimal 0.05 and times it by the number of nickels I have. Since a dime is worth a tenth of a dollar, or just 10 cents, 0.10, I'm going to take it and times it by the number of dimes I have. Now this value right here, this dollar amount, should give me how much money I have in the problem. And here's my system. Okay. Now you have options. You can use substitution. You can use elimination. Okay. I mean, you can graph it if you want to. All right. That's up to you. All right. But algebra is probably the best method to use. When I say algebra, substitution or elimination. So here's your system. Now you solve it. Okay. Look at your notes and you solve it. Okay. Question number 8. All right, Carla is 3 times as old as Lauren. In 4 years, the sum of their ages will be 56. Which system of equations can be used to find the age of Carla K and Lauren L? All right. So once again, let's read the problem one more time to make sure you understand it. So Carla is 3 times as old as Lauren. You know, and like I did in the class, I like to define what my variables represent, which they done for us in the problem already. So K is equal to Karen's age, actually Carla's age. So just to write it out. And L is equal to Lauren's age. That first sentence says Carla is 3 times as old as Lauren. So to get Carla's age, you would have to multiply Lauren's age by 3. Alright, so I know that Carla's age will equal to 3 times Lauren's age. Now, in 4 years, the sum of their ages will be 56. So 4 years from now, the sum of their ages would be 56. So I'm gonna go over here and write 4 years from now. Okay, Carla's gonna be K plus 4 years old. All right, and Lauren is going to be L plus 4 years old. All right, so I'm gonna come here. So now we just simply add their 2 ages together. All right, so as you can see, I gave you the answer for this problem right here. Okay. All right, so it didn't ask you to solve the system. It just asked you which system represents the correct answer. Now, let's look at question number 9. Now, for this one right here, you need to remember the rule. I'm going to just give you the rule for this one. If you are raising a base that contains an exponent to another exponent. The rule says to multiply those exponents. Alright? The rule says to multiply those exponents. So they're giving you what x is. Alright? So simply plugging what x is, use this rule, and you should find the answer. Now guys, make sure you don't multiply the exponent by the base. A power says to take that base, the power says to keep the base, to take the base and times it by itself the exponent number of times. Okay, so if the exponent is 5, you take that base and you times it by itself 5 times. Okay, so you'll get something like this right here. So 3 raised to the 2 times 3 power. Alright, and remember, multiply the exponents, get your new exponent, and then take that base and times it by itself that many number of times. And number 10, rules of exponents again. If you're multiplying with like bases, the rule says keep the base the same and add the exponents. So with that rule right there, you should be able to find out what the answer to number 10 is.